Okay, everyone. Hello, everyone. So, I hope I'm audible. One of you can just write in the chat box and respond if I'm audible. This is week 4 of the presentation, right? And today we are going to discuss the assignment 4. And I'm audible. If I'm audible, request you guys to just write in the chat box. Request one of you to write in the chat box if I'm audible. Okay. Vikas, you have raised your hand. Is there any concerns? Vikas Raj, you have raised your hand. Is there any concern?
No, sir.
Okay, then you can lower your hand and then mute your system and we can commence with the presentation today. I request you all to mute your system. Okay. So just read this question. For the circuit shown in the figure, you are required to figure out the voltage across the 6 ohm resistance and uh, the current and the value of the resistance R over here, right? So here you are not given the value of the voltage V, right? This is the value of the voltage. Okay, so you are required to figure out the source voltage V. So you are required to figure this thing out, right? And you are required to figure this thing out, right? These are the two things which you are required to figure out. What you are given? You are given the values of the various resistances in the circuit and you are given the current here, which is flowing over here, right? So, Vikas, would you like to have a go at it? Like, would you like to tell me how to proceed forth in this particular case? Vikas, you can unmute yourself and then try to have a guess, like how should I proceed forward?
क्या सर?
कैसे करेंगे इस क्वेश्चन को? कैसे आप इसको अप्रोच करिएगा इस क्वेश्चन को, विकास?
सर्किट को पहले इक्विवेलेंट करेंगे,
हाँ हाँ,
उसके बाद रेजिस्टेंस को इक्वल करेंगे.
ऑल राइट. तो विकास ये बताइए, जैसे कि आपने यहाँ पे देख रहा है कि यहाँ पे आपको 3/4 एम्पियर करंट 4 ओम में फ्लो कर रहा है. तो मैं अगर
जी,
पूछूंगा कि 12 ओम में कितना करंट जाएगा, तो आपका जवाब क्या होगा विकास?
9.
ओके, हाउ डिड यू गेट दैट विकास?
सर मल्टीप्लाई करके, जैसे भी आई आर होता है ना.
हाँ, तो जैसे कि अगर मान लीजिए यहाँ पे करंट अगर आई जा रहा है,
जी,
एक मिनट रुकिए. हाँ, तो यहाँ पे जैसे कि दोनों के अक्रॉस में वोल्टेज सेम है विकास, इसके और इसके केस में,
जी,
है ना? तो हम लिख
जी,
सकते हैं कि आई इंटू 12 ओम मस्ट बी
जी,
इक्वल टू 3/4 इंटू
4.
4 ओम,
जी,
है ना विकास?
जी,
तो इस हिसाब से हमको मिल जाएगा करंट का वैल्यू आई इज इक्वल्स टू 3/12, मतलब 1/4
12,
एम्पियर, है ना?
4. जी, जी,
तो करंट जो 12 ओम में फ्लो करेगा वो एक चौथाई होगा, है ना? 1/4
जी,
होगा. So total current which will be flowing into this junction will be equal to Vikas I1 plus I2,
जी,
right? So the current will be
जी,
equal to I total will be equal to I1 plus I2,
I1
right
plus.
Vikas?
जी, जी, जी,
So it will be 3/4 plus 1/4 is equals to 1 ampere, है ना?
1. जी,
Okay. So thank you Vikas, thank you for your help. So you have the current here, right, as 1 ampere. I'm hoping that everyone is following what Vikas just said and then what I'm trying to tell here, right? So the current is
Yes.
equals to 1 ampere at this particular node, right?
जी.
And now you are required to figure out कि resistance और ये 6 ohm में कितना मतलब current जा रहा होगा, right?
जी.
So how do you do that? So क्वेश्चन
So
में ये भी लिखा हुआ है कि क्वेश्चन में ये भी लिखा हुआ है कि 6 ओम के अक्रॉस में 6 वोल्ट है, तो यहाँ पे वोल्टेज 6 दिया हुआ है ना?
जी.
तो अगर यहाँ पे 6 वोल्ट दिया हुआ है तो इसका क्या मतलब है? इसका मतलब है कि यहाँ पे जो करंट जा रहा होगा वो 1 एम्पियर करंट जा रहा होगा,
जी.
राइट? 6 डिवाइडेड बाय 6 ओम इज 1 एम्पियर
Yes.
and the voltage at this point can be evaluated. Let me call this point as B. So this B, ये जो हम यहाँ पे इसको A कह देते हैं, ठीक है? A पॉइंट कह देते हैं. तो VA minus VB divided by the resistance R, sorry, divided by the resistance R must be equal to I total. जो I total
Yes.
हम लोग यहाँ डिटरमाइन किए हैं. तो VA, what is VA? VA is 6 वोल्ट, है ना?
6 volt.
और
Yeah.
VB हमको पता करना है, राइट? एंड डिवाइडेड बाय द रेजिस्टेंस R.
Yes.
R is equals to current total. What is current total? 1
One.
ampere, right?
One.
But then I also
जी.
know the value of VB. कैसे VB का वैल्यू पता है? VB is nothing but 3 by 4 into 4 ओम.
Yeah.
So VB is equals to 3 volt. तो यहाँ पे आप रख दीजिए 3 वोल्ट. तो यहाँ पे कितना आ जाएगा? 3 by R is equals to 1. तो therefore R is
1.
equals to 3.
3.
तो R is equals to 3 ओम आ गया यहाँ पे आपके पास. और फिर अगर R आ गया आपके पास यहाँ पे, तो आपको यहाँ का वोल्टेज भी पता है और 6 वोल्ट है यहाँ पे. तो और यहाँ का करंट भी पता है आपको, 1 एम्पियर है. तो यहाँ पे आपको करंट पता है 1 एम्पियर है, यहाँ पे जो करंट जा रहा है उसके बारे में आपको पता है 1 एम्पियर है. तो टोटल यहाँ पे जो करंट जाएगा दैट विल बी 2 एम्पियर, राइट?
Yes.
So Vikas, if this is 6 volt and 2 ampere current is flowing, then what is the voltage?
3. क्या सब फिर से?
अगर यहाँ का वोल्टेज अगर 6 वोल्ट है ए पे,
जी. जी.
और यहाँ पे जो करंट फ्लो हो रहा है दैट इज 2 एम्पियर,
जी.
तो व्हाट इज द वोल्टेज हियर? वोल्टेज सोर्स का वैल्यू कितना रहेगा?
3 no.
कैसे 3 होगा विकास? आई कैन राइट V इज इक्वल्स टू आई आर, V माइनस आई
जी.
आर इज इक्वल्स टू 6, राइट?
6. जी.
तो यहां से कितना आ जाएगा? V इज इक्वल्स टू 6 प्लस आई इंटू आर, है ना?
Yes sir.
तो यहाँ पे कितना आ जाएगा? 6 प्लस करंट का वैल्यू कितना है? 2 एम्पियर
2. जी. 1.
और इंटू 1, तो यहाँ पे कितना आ
1.
जाएगा?
8 volt होगा.
एक मिनट, कुछ तो गड़बड़ हो रहा है. हाँ, तो यहाँ पे आ जाएगा 8 वोल्ट हो जाएगा, है ना?
Yes sir.
तो यहाँ पे 8 वोल्ट और 3 ओम कहाँ पे लिखा हुआ है? बी पे लिखा हुआ है, तो बी आंसर हो जाएगा
B.
आपका, है ना?
Yes.
So
Thank
this is how you proceed forward, right, Vikas? So
Yes.
you can mute your system now, Vikas. You can mute yourself. So I'm hoping that everyone has understood how to approach this problem. So you proceed forward. How to approach these kinds of problem? You proceed forward with what is known in your system. So what was known in the system? Two things was known. One is that the value of current over here. This thing was known to you, right? And the other thing known to you was the voltage across this 6 ohm resistance. So this was known to you. And then you used what? You used basic case KVL. You used KVL to solve this particular question, right? So every question which I have been discussing since the last 3 weeks and today also in the 4th week, is solved using KCL and KVL, right? So it is just the application of these two things in different formats, like in nodal analysis or in mesh analysis. So what you guys need to do is you guys need to practice more question so that you understand where to implement and how to implement, right? Things. So let me proceed to question number 2. Uh, so the question number 2 is stating, figure out the voltage VAB in volts, right? So let me just ask another person now to help me. So uh, 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 excuse me, let me just okay, I cannot see the people who have joined, so just give me a minute. Okay, I've talked to Vikas. Let me talk to another person. So Anarika, are you here? Anarika, can you unmute yourself and help me figure out question number 2? Anarika? Anarika, can you hear me? Anarika? Guys, please be responsive if you can hear me. It would be helpful to have more interactive sessions. Okay. Kalpana Satish, are you here? Kalpana Satish, can you hear me? Okay. Mahesh, can you hear me? If you can hear me, please, Mahesh, respond. Like, guys, can you hear me at all? Like, am I audible? One of you, please write in the text. Like, Abhishek Singh Rajput, you have written.
Audible, sir.
All right. So, Hassan, can you help me figure out question number 2? Hassan?
Yes, sir.
Okay. Can you help me figure out question number 2?
Question is to find the voltage between node A and B.
Right. So, how do you proceed forward? Tell me first, Hassan, is there going to be any flow of current over here in the resistance that I have just indicated? Is there going to be a flow of current there?
So I think no, sir.
Why do you think so, Hassan?
There is no amperes given there.
Ampere?
Yes, sir.
No. I did not understand why there is not going to be a current. For current to flow, what is required? A potential difference is required, right?
B. Yes, sir.
Right. And can you tell me what's the potential difference in a loop, self loop kind of a thing?
Sir, where, sir?
Right. So no current can flow in this because if current flows here, it has to have a path to return back to the source, right? So for this particular 8 volt, this thing is a kind of a self loop, right? Did you understand? Did you understand this? What I'm trying to say? Okay, somebody is responding in chat also. I cannot see the chat. Okay. Chat. Okay. So what I'm trying to say here, Hassan, that if current starts from here, it will terminate back to this negative resistance, negative polarity of the voltage source, and the current which is originating from this current source will eventually end back in this, right? So it cannot go in this path because if this current goes here, it does not have any path to return back, right? It cannot return back by the same path because the voltage, there is no voltage difference. So it cannot flow if there is no voltage difference. So therefore, this current will not find a path here, and this current similarly will not find a path here, right? So no current flows here in this particular 3 ohm. So what you said was correct. No current will flow. I am just talking about the reasons of the claim, right? That no current is going to flow. Okay, so if no current flows, then can you figure out what is the voltage Vx in this 6 ohm resistance, Hassan?
Yes, sir.
हाँ बताओ बताओ हसन 8 डिवाइडेड बाय 6 प्लस 2 है ना करंट आएगा so this is equals to 1 ampere that you will multiply by 6 ohm to get the voltage Vx, right? So Vx is equals to 8, right? 8 volt, correct Hassan?
Yes, sir. Yes, I told, sir.
Right?
Right.
Sorry, 8 कहाँ से आ जाएगा हसन? गलत बोल रहे हो ना? 6 वोल्ट आएगा ना? 6 into 1 is 6 volt, right?
यार मुझे को हिंदी का मालूम नहीं है.
Okay. So what
थोड़ा
जो हम कह रहे हैं हसन हम क्या कह रहे हैं कि 8 वोल्ट को तुम डिवाइड करोगे रेजिस्टेंस से. So for the other colleagues over here who cannot understand Hindi, I'll just say that in English as well. So 8 volt is available with you. तो 8 वोल्ट को तुम 6 ओम प्लस 2 ओम 6 है उससे डिवाइड. हिंदी समझ में आती है ना सर?
क्या सर?
ओके हिंदी समझ में आता है या इंग्लिश समझ में आता है? क्या समझ में आता है तुम्हें?
इंग्लिश में सर.
हाँ ठीक है. सो यू हैव 8 वोल्ट्स विथ यू.
थोड़ा हिंदी मालूम है.
Okay. That's what, like some of guys are not aware of English. So you have 8 volts with you. What you're going to do is you are going to divide 8 volt with the total resistance, which is 8 ohms, right? To figure out the current in this particular loop. And then the current which you get, you're going to multiply it with 6 ohm to figure out the voltage Vx, right? It's very straightforward, right? Ohm's law. And then the voltage Vx will become equal to 6 volts, right? Now, what is the current which is going to flow in this particular branch? If it is equal to 2 times Vx, what's going to be the current, Hassan?
Sir, 12.
12, correct. So, what is the potential at point B with reference to this particular point? Let me call this as C, let me call this as D. With reference to C, what is the potential at B? Tell me, Hassan, what is VBC?
Sir, C is 0.
C is not 0, C is floating, right? C is floating here, Hassan. So what is the potential of B with respect to C? What's the current flowing over here? You just mentioned, right? Current is 2 times Vx, that is 12 ampere, right? So 12 ampere into 3, right, will be the potential drop in this branch, right? So what will be the value be? It will be 36 volt is equals to VBC. Correct, Hassan? Respond yes or no, Hassan?
Sir, yes, sir.
Right. Why it is so? Because 12 ampere current is flowing and the total resistance is 3 ohms. So 12 into 3 is 36 volts, right? Okay. And we already know the potential at point A. What is A potential with respect to D? VAD is nothing but 6 volt as we had figured out earlier, right? 6 volt. Now the potential at D is equals to potential at C. The reason is the same which we had discussed earlier. No current is flowing here. So if no current is flowing here, that implies that the potential drop is equals to 0, right? So both these node potential are equal, and therefore you can write that this potential VAB is nothing but VAD minus VBC, and you can write it as VAD plus VCB, and therefore you can write, since D and C are at same potential, you can write is equals to VAB. So basically, if you can subtract these two quantities, you will be figuring out the voltage VAB. Did you get that, Hassan? Did you get that, Hassan?
Yes, I got it, sir.
So what is VAD? That's a 6 volt. What is VBC? That is 36 volt. So what's the difference between the two? That is equals to 30 volt with a negative sign. Right? So that gives you the D as the correct answer. Did you get that, Hassan?
Yes, I got it, sir. Option D.
Okay. So here the important thing is that you should understand which part of the circuits are physically connected but are electrically like at zero potential, right? So this particular branch was the key to understand here. Like if you can figure out what would be the state of the branch 3 ohms, right? Then you can figure out the solution of the question, right? So let's move forward, Hassan. So in question number 3, it's required to determine the power which would be flowing in the 6 volt, right? So where's the 6 volt? Here's the 6 volt. So you need to figure out the power over power in 6 volt. So someone else, please help me out now. Okay. Okay, what is it not responding? Yep. Okay, Rohan, are you here? Rohan Mali? Rohan, can you unmute yourself? Okay. Dr. P. Logan. Okay. Are you also auditing this? Are you also auditing this course, Dr. Logan? I can chat. Okay, you don't have your audio with you. Okay, like it's difficult for me to see the chat. Like I'll be going to the other screen. Okay, but then I'll try to manage. Okay, yep. So how would you proceed in this? Like you are required to figure out the 6 volt, the power in the 6 volt. So power is equals to voltage into current. Am I right?
Yes, sir. Correct, sir. V into I.
Right. So there are two currents which are given to you, current sources which are given to you, 1 ampere and 2 ampere, right? And we can see that there are 3 loops with us, right? So the easiest way to proceed forward can be a mesh analysis, right? Because 2 mesh currents are known to you. So the only thing which is not known to you is the current in the third mesh, and you can figure that out using the mesh analysis. So I think that would be the easiest way to proceed forward. So yeah, if none of you have any objections to that, let me just proceed forward with mesh analysis. So the current over here, I can just write it as I1, I2 and I3, right? I1 is known to me as 1 ampere, I2 is also known to me as 2 ampere, oh minus 2 ampere because the current direction is different, and I3 is something which I have to figure out, right? So I can take the I3 direction to be this, so that power is being delivered by 6 volt, and we'll figure it out, like whether it is delivered or not delivered. So the direction of current I3 is this direction, right, coming out of the battery or the voltage source. So write the mesh equation in this loop. So we'll start from this point.
Sir.
Pardon?
Sir, how you determine the direction of the I3?
I've just taken the direction of I3 to be positive. Like you can take it to be negative. It does not really make a difference. Like I just like to keep things positive. right?
Okay,
So,
sir. Okay.
so it does not really makes a difference. Like you can take it very well negative and then proceed forward. It won't make a difference, right? But it's just my nature to make the things positive, and then finally, if it is coming out negative, I'll mark the negative. It's just my nature. So, uh, so yeah, I was saying about 6 volt, but then let me just okay, then little too much of confusion. Just let me keep the things as they are, right? So it's just 6 volt is there, right? 6, and then the person who had asked me this question, why I had taken the direction to be this direction. Can you please unmute yourself and then help me write the KVL? Who had asked me the question, the last question? Please unmute yourself. Okay, yeah, not like it would be great if you can unmute yourself and then have a discussion. It would be helpful for you and for the others. Uh, but anyways, like let me proceed forward. So it's 6 volt minus I3 into 4, right? And then the current is going here in this branch like this, and this current is also in the same direction. So it is
6I3
minus
minus 6I1.
minus I1. So it will be added together into 6 ohm. You are right. Go forward. So it will be I3,
2I3
I3.
minus
So this
I2.
current is also in the same direction, right? So I2 into 2, and you return back to the same point, so it is equals to 0. Correct?
Yes, sir.
Right. So now we know the value of I1 and I2, right? So you can just substitute it here, right? So 6 minus 4 times I3, and then 4 and 6 will be added together, and then this 2 will be added together, so it will become 12, 12 times I3. And here we know that I1 is equals to 1 ampere, right? So it will be minus 6, right? And then I2 is nothing but minus 2. So it will be plus 4, right? And then this will become 0. So 6 and 6 gone. And then this is like 3 times. So I3 is nothing but 1 by 3, right? And once you have the value of I3, so I3 is actually flowing out. So what the direction which we have assumed is actually the correct direction. Had it been negative, it would have been negative. And then you can just figure out the power by writing I3 into 6, which is nothing but 2 watt, and it will be delivered, right? Because it is coming out of the battery. So it is 2 watt delivered. Where is 2 watt delivered? So A is the point and A is the answer, right? So I
Yes,
am
sir.
hoping that you guys have understood this particular question, right? So again, the principle here which I had used was mesh analysis, which is based on simple KVL, and I had to understand which thing I should go for, right? KCL, KVL, what should I use? So that is again dependent upon how much you are practicing. You can do the same question by other methods like nodal analysis. It will be solved. The only thing is that it will take a little more time and effort, but then it can be done. But then time is like critical during examinations. So you need to figure out what's the simplest approach, right? And then which will come only when you practice. So let's go on to question number 4 over here, right? And let me ask someone else to help me out here. Okay, show people. Okay, so only these many people have joined today. Okay, okay. Manjari Mehrotra, can you hear me? Manjari, can you hear me? Okay, seems like He's not available at that time, like cannot respond. So just let me proceed forward, and then if there is any doubt, you let me know, right? Okay. So you need to determine the power associated with the 1 volt. Where is 1 volt? Here is the 1 volt battery. So you just take the current which will be flowing out as this direction. Right, so I'm just assuming the same thing, positive flow of the current out of the battery, and then I have to figure out this current. And if I figure out the current, then the power associated will be 1 volt into that current. So let me call that current as I, current I, right? So I have to figure I, and that will give me the power. So, okay. So what is uh, so again, what is the potential if let's say I'm grounding this particular point, right? Then what's the potential at this particular point with reference to this particular node? 20 volts, right? No problems here. So this is 20 volt. Let me call it A. Let me call this B. Let me call this C. Let me call this D. And this is F anyways. F I have grounded. So VA is equals to 20 volt, all right. How about VB? VA is equals to 20 volt. VB is equals to 5 volt, right? What is VC? If VB is equals to 5 volt, then VC will be equal to VB minus 1 volt. I'm hoping that I'm clear. So it will be 4 volt. And what will be VD? VD will be equal to VC minus 6 volt is equals to 4 minus 6 is minus 2. Minus 2 volt, and then of course when I'm writing VD, it's with respect to this particular point, right? So everything is with respect to, right? So if this is VD, then this particular node, let me call it ABCDE, because I've taken this to be F, right? Then VE will be equal to VD minus 10 volt is equals to minus 12 volt. Right, so I have all the potentials with me at different node, right? If I have the potentials at various node, I can figure out the value of current. That's easy to figure out. So what will be the current which will be flowing in this particular branch? It will be 20 minus 5, 20 minus 5 because B is at 5 volt. So 20 minus 5 divided by 5. So the current will be equal to 15 by 5, that is 3 ampere, right? Okay, what is the current which will be flowing in 8 ohms? The current here. So it will be VA minus VC divided by 8 ohms, right? So VA is 20, right? VC is equals to 4. So that the difference is 16. 16 divided by 8 is nothing but 2 amperes. Okay, and how about current over here? Current over here. So F is at ground potential. I know the potential of C with respect to F, right? Because that I have figured out. So that is equals to 4. So this is nothing but 4 volt. VC is 4 volt. So current will be equal to 4 divided by 4 ohms, that is 1 ampere. So the current here is 1 ampere. Okay, and is there going to be any current which will be flowing in this path, C to D? So for figuring that out, how should you proceed forward? Like, is there a potential difference between C and D? Is there a potential difference between C and D?
No current flow, sir.
Okay. I'll ask you why no current flows.
There is no elements.
Pardon? Pardon? Somebody just said
There is no
something.
elements resistance.
Ah, correct. So no current is going to flow because the path is not complete. If current starts flowing out from here, it has to have a path back, right? But then since there is no path, no current would have flowed, would flow. Let's say hypothetically speaking, if this point was also grounded, right? Then would the current have flowed through 6 volt? I'm just giving a hypothetical situation. This is not present in the circuit. I'm just grounding this point also. So would the current have flowed through 6 volt? Somebody like the person who had said no can answer the same query now again. So this particular node is grounded. This particular node is also grounded. So is there a path for the current which is coming out of 6 volt to find a path back to the negative polarity? Yes, there is. Like this current coming out can flow in the ground potential. It can again flow via the ground back into the circuit and then complete the path, right? So in the situation which I have hypothetically developed, right, the current can flow. But then since the question does not give you that, like in the question this is a floating potential, right? So there is no grounding of this particular point. So no current is going to flow in this particular branch, right? So that is all right. All right. So no current flows in that particular branch, and therefore I can always apply nodal analysis at this particular point. So the nodal analysis will say that the current I is nothing but 2 amperes at this point I'm applying. So this current is equals to 0, right? There is no current over here. So I'm writing this is my sourcing current, right? 2 amperes. So I'm writing 2 amperes as I plus 1 ampere, right? Because this is flowing out and this is also flowing out. So you can have the value of I as 1 ampere, and if this is 1 ampere and it's flowing out, therefore it will be 1 ampere and delivered power, right? So this will give you the C as the correct option and is there in the accepted answers as well. So I'm hoping things are clear to you, right? And then you understand when the current can flow and when the current cannot flow.
Sir,
All right, someone is asking a question, right? Go ahead.
sir, 2 amps are leaving, sir.
Yes, 2 ampere. Okay, you did not understand the KCL, है ना? KCL फिर से बताऊंगा ना?
बताओ.
हाँ. So I'll go back to the KCL. So just let me ask you if I1 plus I2 plus I3 plus so on up to IN, if I add them, I1 plus I2 plus I3 plus so on up to IN, if I'll add them, the sum will be equal to 0, right? Right, Hassan?
Yes, sir.
Right. So
Yes,
this is the fundamental law. Like there cannot be
Yes, sir.
there cannot be a net current flowing into a single node, right? Like it has to flow out of it. So if there is no outflowing current, the sum must add up to 0. So same thing is happening over here as well, Hassan. That you have the node C available with you, and from the node C, 4 currents are can flow. One can be 2 ampere, one can be this I current, and one can be the outgoing current as 1 ampere, and one current is flowing over here. This current we know as 0 ampere, right, Hassan? So what you do is you figure out the total current which is flowing into the node C. So what's the total current? 2 ampere is flowing into it, right? And then minus I current is flowing out of it, right? And minus 1 ampere current is flowing out of it, and minus 0 ampere current is flowing out of it here, 0 ampere current, and this must add up to 0. So basically this is implying that 2 minus 1 ampere, 2 ampere minus 1 ampere is 1 ampere, that is equals to the current I. Did you get that, Hassan, now?
Yes, I got it, sir.
Okay, so 1 ampere current is flowing
Now
out,
I into
then you
one.
multiply it with the voltage, right? This
Yes,
is
sir.
what we had
One
started.
watts.
So 1 watt,
Delivered.
and then it's delivered. Did you understand that, Hassan?
So how to find this delivered absorbing current?
Uh, how to find?
It's delivered or absorbed.
Delivered or absorbed. Okay. So the current direction I have taken is this direction, right? If the current is coming out to be positive, then that means that the direction we have chosen is correct, right, Hassan?
Yes, sir.
If we had taken the direction as this direction, then this equation would have changed, right? It would be if the current direction was into the battery, let's say I was taking a power is being absorbed, then the current direction would have been this, right? And this equation would have changed. So it would be 2 amperes plus current I, right? And everything else would have remained the same. But then the current would have come out to be minus 1 ampere, right? So when you are getting minus 1 ampere, that implies that the current direction you have chosen is wrong, right? The current direction should be in the positive direction because it's minus, right? So the current would actually be flowing in this direction because it's a DC current, so positive and negative is basically implying a direction, right? So the current would be flowing in this direction because the current is coming out to be negative, and therefore again you can take the direction to be positive, that is flowing out of the positive battery, and then you can multiply it to figure out it's being delivered, right? Because the current is coming out of the positive plate. So if the current is coming out of the positive plate, it is power being delivered. If the current is coming into the positive plate, it is power being absorbed. Did you get that, Hassan?
Yes, I got it, sir.
Okay, that's good. So let me proceed forward now. So the question number 5 is again related to power, right? The question is asking you to determine the power which will be flowing out via the 2 volts battery. So tell me, how should I proceed forward, Hassan? What's the way to proceed forward, Hassan?
Sir, node.
Node. Okay. Anything else you can do? Like what other things you can do? You can do also the mesh analysis, right?
Yes, sir.
Yes, you can do the mesh analysis. You can do the node analysis. Which one should you prefer? Why should you go with mesh or with nodal analysis? Like if you're given two options and you have to select one, which one would you select and why?
So, and questions 2 volts is between the two nodes.
Okay, so tell me this, like what do you need to determine? You need to determine the power, right, Hassan? That's what the question is
Yes,
asking.
sir.
So basically it implies that you need to figure out the value of the current, right?
I.
Flowing here, right?
Yes, sir. Yes, sir.
Now, even if you'll determine the value of the potential at this point and this point, right?
Yes, sir.
It won't help you figure out the current which is flowing over here until unless you have the value of the current which is flowing here and here and here and here, right? Because the voltage can have any value of current which is flowing in it, right? There is no resistance, right, which you can figure out the current, right? Did you understand what I'm saying? So
Yes, right. Mesh current is easiest way to find.
right. So like if you are going to do nodal analysis, you will have to do few more calculation steps to come up with the final value of the current which would be flowing out or in of the battery, right? But if you will do mesh
Yes.
analysis, then the answer would be taking the least number of steps and having and thus help you save time, which is critical during exams, right? But it's not that you should not try out nodal analysis. Like you should certainly go ahead and try out nodal analysis and then figure things out for yourself, like how much time it's taking, what's the step involved, and then those kinds of things, right? So, and is there any other methods of figuring things out? Like, have you read superposition theorem?
Yes, sir.
Have you read this? Hassan, superposition theorem.
Yes, sir.
So,
Yes, sir.
uh,
Keep
uh,
one voltage source alive and another is
correct. So, I'm hoping that the professor in this particular course has taught you that, right? So, you can of course use superposition theorem to figure out the branch current, and then you can add them up to figure out the total current. That's also an approach. So, there are many approaches to solving a problem. You can explore different approach and then figure things out as you go along, right? So for the time being, I can just assume the current direction to be like this one, I1, and you can take the abnormal direction according to me, like current flowing into the battery, so I2, and then I can take this as I3, right? So same three directions current, right? Okay, and now you can write the equations, right? But then you know that I1 is equals to 3 ampere, right? So basically you are left with two variables, right? And there are two meshes, independent meshes. So you can solve those two variables using those two independent mesh equations, right? So just let me write that. So it will be 12 volt minus I3 into the resistance 1 ohm minus 3 into I, okay, 3 into I3 minus I2 is equals to 0. So why minus I2? Because I2 direction I've taken like this. So I3 is flowing like this and I2 is flowing upward direction. So the effective downward current is I3 minus I2. And since I've taken the current effective direction as negative here, so I've just like minus sign is there because you are flowing in the direction of current. And you have this particular equation with you. The second equation is so how much time do I have? Just let me see the time left. Okay, 10 minutes is remaining. So in the second equation, you can just flow from this particular point. So just let me go upwards now. So it will be 3 with a minus sign, I2 minus I3, right? And then minus 2 volts, and then current is flowing like this. So I can take the downward current as I2 minus I1 is equals to 0. So you have this thing with you, and then you have the current I3 with you. So this is nothing but 3, and then you have two equations now and two variables now, and then you can solve them to figure out the value of the current I2, right? You can figure this out, right? Using the two equation, two variable, you can solve them, and then you can figure out the value of current I2. And then once you have the current I2, the power will be equal to 2 volt into I2. And let's say the current I2 direction is this as I have taken here. Then the power will be absorbed or released, delivered. Hassan? Hassan, you can unmute yourself and then say.
yes, sir. Yes, sir.
Yeah, so did you understand the solution first? Like what I did you understand it?
So in the second equation I can't get it, sir.
Okay, second equation you did not get it. Let me just repeat myself then. So the current is flowing in this particular branch. I have taken that current will be, and the current direction is like this. Let's say I'm moving, taking the effective current like this. Then the value of the current will be equal to, Hassan? Hassan, you can say that.
Hello, sir.
The current is in this direction. Then the value of the current in 3 ohm will be equal to?
Minus 3 I2 minus I3.
Right. So I2 minus I3, right? I2 minus I3, right?
Yes, sir.
Okay. And since you are flowing in the direction of current, like you are taking like you are taking the KVL in the direction of current, then therefore it will be negative sign, right?
Okay, sir.
So you are flowing from this particular point towards this particular point, right? So basically what you are writing here is that, like when you are writing the KVL equation, it is effectively, let me call it as point B, right? This is point A, then this is point C, अरे यार, this is point C and this is point D. क्या हो रहा है? So this is point D. So what you are doing is you are writing VBA, then you are writing plus VAC plus you are writing VCD plus you are writing VDB is equals to 0. So therefore, if you'll add this all up, so this is the same vector. You are seeing that, right? And this is the same thing as this. So effectively you are getting VBB. That is the potential of B with respect to itself. This is what. So in a self loop, it is equals to 0. This is the root. This is the way you derive a KVL. Like you go in a loop, and then the loop voltage will be equal to 0. So you are going in this particular loop effectively, Hassan, right? And then the loop voltage must be equal to 0. Now VBA, when you are writing, did you understand what I wrote here, Hassan? Hassan?
Yes, yes.
You understood this particular equation, right?
So I only have doubt in the second equation. Minus 3 I2 minus I3. It's okay.
All right. That I got it. But then, did you understand this one?
Minus 2.
Did you understand this equation which I have written over here at the bottom of the page? The derivation of KVL. That is a derivation of KVL. That is how you come up with the KVL in the first place, right? So the equation number 2 is nothing but a deduction from this generalized equation, right? So I2, you have taken the direction I2 current like this. So I2 minus I3 will be coming in the top. If you take 3 ohm, the current which will be flowing out from it is I2 minus I3. And since you are flowing out from this particular node, right? So VBA, if I'll ask you what is the potential VBA, you will say I2 minus I3 into 3 ohm with a negative sign. Right, Hassan?
Right.
So that is what I have written over here. If you see what is VAC, then VAC is nothing but higher potential, lower potential. So it is a minus 2 volt, right? So you can write minus 2 volt over here, right? And okay. This is what you are saying. Yeah, I've somehow missed a sign over here. I've somehow missed over a sign over here. Okay. I got it. What's the confusion here? So, okay. Yeah, my mistake. So I just had missed this sign over here. Like this is minus 2 and the current which is flowing down here is I2 minus 3 and that will be multiplied by 4 and that will have a negative sign over here and that will be equal to 0. Now it is clear to you, Hassan, right? So I had made a mistake over there. Now it's clear, right, Hassan?
Yes, sir. In 4 ohm resistor, 4 I2 minus I1. I'm right?
I2 minus I1, right? I2 minus I1. I1 is equals to 3 ampere, right, Hassan?
Yes, suppose that 12.
So I2 minus 3 ampere is the current, effective current, right?
Yes, sir.
Right. So I2 minus I1 you know as 3 ampere. So I2 minus 3 ampere into 4 and that thing will come with a negative sign because you are flowing in the direction of current, right?
So you wrote that 2 in the 4.
No man, I have not written, like 2 is over here. minus 2.
Yes, sir. Okay, sir.
So there is this first term, there is this second term with a minus 2 sign, and then there is this third term. Understood, everyone? So you can solve these two equations, and then you can figure out the power which if it is being absorbed or released, and then you will get the answer as C, right? So it will be the current is going to come out, and then since it is 8 watt, that implies that 4 ampere current would be flowing. So I2 value is going to be I2 value is eventually going to be positive, right? Because it is being absorbed according to that answer. So the current direction we have chosen is right, and I2 will be coming out to be as is 4 amperes. So you guys go ahead and solve this like after the class, right? And then if you have any doubt, you ask me. So there is one more question I need to discuss before I wind up, right? So let me address that particular question, and then maybe we can wind up for the day, and then you can log into the other TA's class, and then she will be discussing over there. So let me quickly discuss this. In the voltage divider circuit shown in the figure 6, the no load value of the voltage VD is 12. Okay. When the load is of R0 is attached across the terminal X and Y, VD drops to 5 volt. Okay. Find the resistance R0 in ohms. Okay. So like I request all of you to mute yourself. So in the no load condition, the voltage VD is nothing but R upon R plus 30 into 80, right, from the voltage division, resistance division. So this is given to you as 20. The question is saying that this is equals to 20. So that gives you 4. So therefore R is equals to R plus 30. 4R is equals to R plus 30, and therefore R is equals to 10 ohms, right? So you got this value. Okay, good. Now you are saying that a load of resistance is attached, and then VD comes out to be 5 volt. Okay, so let the effective resistance be equal to Rx. Then Rx plus divided by Rx plus 30 ohm into 80 volts will be equal to 5 according to question, right? So this is nothing but 16, and therefore Rx is equals to 15 by 2, that is 2 ohms, right? So Rx is nothing but 2 ohms, right? I'm just doing the calculations by my mind. So this is Rx is equals to 2 ohms, but I also know that Rx is equals to R into R0 plus divided by R plus R0, because these two things are now in parallel, right? And this is given to you as 2 ohms. You have just calculated it, right? But you also know that R is equals to 10 ohms. So you can put here 10 into R0 divided by 10 plus R0 is equals to 2, and this is going to give you the value as 5 R0 4 5 4 2.5, right? 2.5. R0 as 2.5, and 2.5 is here, and A is the accepted answer. So this is a very straightforward question which is based on simple resistance divider and a parallel circuit. Like, so there are two concepts used over here: resistance divider, and the second thing was parallel circuit equivalent resistance. Parallel circuit equivalent resistance. So I'm hoping that these two things are like you have studied. I've discussed this thing also in the previous assignments, and I'm hoping that the professors in the lecture have covered this. I request you to solve this these 6 questions independently, and then try different things like nodal analysis and other methods, right? If there are any problems around the same, we can have a discussion on it in our next discussion, right? So I'm hoping you guys understood this question, right? If there is any problem with the solution number 6, you can feel free to ask it now. So if anyone did not understand the problem number 6, request you to just ask it now.
No, sir. Understand.
Okay, that's great then. So thank you guys for coming and joining today. I'll be looking forward to meeting you guys next week on
Thank you, sir.
Tuesday. So bye bye.
Bye. Thank you so much, sir.
Yeah.